Yeah. Okay. Hi everyone. So schedule. Our first homework assignment is due Friday midnight. So it's not in class, right? It's you do it in Blackboard. Have you? So you haven't started. Uh, you have unlimited attempts. Okay. So you click the homework. It will direct you to my Open Math, and it has 25 points. And so this is the questions, and you have 25 questions. Uh, so please review your notes and then do the first attempt on your own. And then once you finish your first attempt, you can look at which problem you get wrong. And then you can look at the solution. So solution is not on Blackboard, is on our course website. See, this is a solution. Maybe I can copy those. Okay, maybe I can copy those so you can see this links in Blackboard too. So edit. Okay, let me paste right here. All right. Okay, so these are the sample solution. Okay, because MATLAB, every student will get a different version. It will randomize the questions and yes, and change the number a little bit. So the second attempt, you can look at the sample solution and follow the steps and see what's wrong, and then you can fix your work. Okay, everybody. So please start earlier because you want to get perfect scores, right? So save time, then you can change. Yes.
Is it due at the end of the day?
Yeah, the 11:59 p.m. Yes, right. But if you have questions to ask me, you can ask me on Friday in my office hours. And solution. I try to write down the stats and how we think in the solution, so you can like follow. All right, so that is the homework. So today we talk about limits. Yes. So big idea. A limit is the number to which a sequence of ever better approximations converges. Okay. So definition. Suppose the function f of f is defined for all x near a, except possibly at a. If f of x is arbitrarily close to L as we like, for all x sufficiently close but not equal to a, we write the limit x goes to a, f of x equals L. Let's draw some picture. Okay, so let's say this is 1, let's say this is 2, and our function looks like this. Okay, and let's see, this is 1. So this is the graph. Do you see an open circle here? It means this point is missing. Do you see a solid circle here? So the point is right here. So in this case, so this is f. F of 1 is what? 1 is the solid point, right, everybody? So f of 1 is 1. Oops, sorry. Yes, sometimes I press the buttons by mistake. Okay, 1. And what is limit? So let me get, how about green color? So you let x getting close to 1. Okay, so x is not exactly 1, x is getting close to 1. Then you are on this piece. Do you see your function, the y value is getting close to 2? Do you see that, everybody? And this is from the left-hand side. And also, if you let x getting close to 1 on the right-hand side, and then your point is kind of like here. And then go, 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 go. Do you see you're also getting close to y? So the y getting close to 2. So 2 is the limit. It's the limit when x approaches 1. The f of x equals to 2. Okay, everybody? Let's write it down. The limit x goes to 1, f of x equals 2. So you get f of x is arbitrarily close to 2 when x is close to 1. Okay, so this is the limit. All right, and you can see the limit of f of x as x approaches a equals to 2. In this case, it does not mean f of 1 equals to 2. F of 1 could be any other number, or it can be not defined, right, everybody? So if this point is missing, then you get f of 1 is not defined. So the limits and the function values, they might not be the same, okay? So later on, yeah, in this chapter, we'll talk about continuous function. Continuous function is when your f of x and the limit, they're equal, okay? So you don't have a hole, so it's continuous. It's kind of you draw the graph without lifting the pencil from the paper. So you don't have any holes there. Okay, everybody? That's continuous. This picture is not continuous. So, right. We'll talk about that more later. All right, let's look at example 1. Evaluate the limit. X goes to 2, and the function, we have x minus 2 over x squared minus 4. Okay? And this is the same function. So we let x goes to minus 2. Okay. So how do we compute limits? Let me write down the steps. So I hope like every time when we see a new type of problem, I write down the steps. Okay, when you see a different example of the same type, you can follow the step and work on that problem. Attendance. Yes, that's the attendance alarm. Okay. Thank you. Okay, so how do we compute limits? This is a step. Step 1. You plug in the number to see what happens. If you get a number, that's good. That's the answer. But if you get something like 0 over 0, that means there is a bad guy. Then we need to cancel the bad guy. Okay, so for example, let's look at this problem. Alright, so here, see, x goes to 2. Let's try to plug in 2. Okay, when we plug in 2, do you see the numerator? We get 2 minus 2. Denominator, we get 2 squared minus 4. Yes? Do you see? What's 2 minus 2? 0. And the denominator, what is 2 squared? 4. 4 minus 4 is also 0. Right, everybody? Oh, okay. You know, 0 cannot be in the denominator. It's not defined. Right, everybody? So 0 over 0. What's that? Okay, so this is not good. So this is the case. If you plug in a number and you get a nice number like a 5 or 12 over 7, if you get a good number, that's good. But if you get something weird like 0 over 0, that means you need to do more stuff. Okay, there is a bad guy. We need to cancel the bad guy. Okay, so in this case, what do you do is, so step 2, when you see 0 over 0, it depends on the function, okay? If you see polynomials, let's try to factor the polynomial. Okay, let's see here. So limit x goes to 2. The numerator x minus 2, because it's already a linear factor, right? You cannot factor further. Questions? Yes. Oh, why do we choose 2? Because the problem says x goes to 2. Yeah. See? The problem is asking, what is the limit of this function as x approaching 2? That's why we plug in the 2 and see what happens. But if we get 0 over 0, that's weird because we don't know what 0 over 0. Do you know what 0 over 0? We don't know. So we need to do more. And when you see it's a fraction, so you have polynomial in the numerator and denominator, then factor it. But you look at the numerator, x minus 2 is already linear. Can you factor further? No. But the denominator is a quadratic. Can you factor further? By, how do you factor it? Yeah, very good. X plus 2 and x minus 2. Oh, do you see the bad guy? X minus 2 is the bad guy because when you plug in x plus 2, 2 minus 2 is 0. This bad guy makes the numerator and denominator 0. Yeah, everybody? So, in this case, we can cancel the bad guy, right? So we cancel the bad guy. The reason why we can cancel it is because x is approaching 2, but x is not equal to 2. That's why we can cancel. Right, everybody? Mm-hmm. Yes. So here, x is not equal to 2. We just say x is approaching 2. It's like I'm getting close to you, but I cannot be you. Right? I cannot, right? I cannot get into your body. That's weird. So only approaching it, but not equal. That's why we can cancel. So we have limit x goes to 2 and 1 over x plus 2. So far, so good, everybody? All right. And by the way, here, leave some space because there might be other type of problems. So step 3, after you cancel the bad guy, you can plug in the number again. All right. Now we plug in the number again. The number x goes to 2. See? You replace x by 2. Oh, what is that? 1 over 4. So the limit is 1 over 4. So 3 steps. You plug in number first. If you get 0 over 0, that means there's a bad guy. The bad guy makes the numerator and denominator 0. Okay? And then if you have rational functions, try to factor the numerator and denominator. Okay, everybody? Mm-hmm. And then after you plug in, after you cancel the bad guy, you can then plug in again. All right. Okay. So this is the limit when x goes to 2. How about when x goes to minus 2? All right, when x goes to minus 2, let me use purple color. Let's see. If you plug in negative 2, what happened to the numerator? We have numerator is negative 4, right? But your denominator is still 0. Right, everybody? Yeah, this is undefined. If you write something like this is undefined. But the problem is here, x is getting close to minus 2. X is not equal to minus 2. Right, everybody? So, okay, we need to separate into cases. If, case 1, if x goes to minus 2, so this symbol means x is going to minus 2 from the right side. You know, the right side is more positive, the left side is more negative, right? So this means x is going to -2 from the right. You're going to this direction, okay? So if I draw the picture, yeah, x is not equal to -2. So that's why when you're getting close to -2 from the right, okay, let's see. Well, in this case, the x plus 2 will go to 0 from the right. Okay, why is that? Well, when x goes to -2 from the right, it means x is greater than -2. Do you agree? And when you add 2 on both sides, you get x plus 2 is greater than 0. Is that okay, everybody? So x plus 2 goes to 0, but it's greater than 0. So you go to 0 from the positive side. Okay, everybody? Mm-hmm. All right, so in this case, what's the y? Remember y is this expression, but you can simplify it. You get x plus 2 and x minus 2. And do you remember the x minus 2 cancel, right? So you have 1 over x plus 2. Okay, you simplify it. And now you have your numerator is a constant, right? And your denominator is something goes to 0. And we know 1 over something goes to 0. This is going to be a very big number. Do you agree? So keep in mind, 1 over 0 plus, it will be positive infinity. 1 over 0 minus, it will be negative infinity. Okay? And this is not just 1. It's any positive constant. Over 0 plus is plus infinity. Over 0 minus is minus infinity. Okay, if you have a negative constant, you count how many negative signs. 2 negative signs make it positive. Okay? All right, so that's why here we get minus. So this goes to positive infinity. Yes. Okay, so we can write it down. All right, write it down. 1 over 0 plus is infinity. 1 over 0 minus is minus infinity. Write it down. And when x goes to -2 from the left, we have x plus 2 goes to 0 from the left or right? Left or right? So this is from the left, right? Yeah. It means x is less than -2. When you add -2 on both sides, x plus 2 will be less than 0. So it's approaching 0 from the left. Yes? So 0 minus. Therefore, y equals 1 over x plus 2. This is like 1 over 0 minus is negative infinity. Okay, everybody? So, therefore, the limit when x goes to -2, okay, of the function does not exist. So this notation means does not exist. DNE. You can just put DNE. Okay? Because you see the left hand side, and here I give you the picture, but in the exam I will give you the picture. Okay, everybody? You see how here the left hand side, your y goes to minus infinity, right? And it matches with our work, right? And when x goes to -2 from the right, the y goes to positive infinity. The left side and the right side limit do not match. Therefore, the limit does not exist. Okay, everybody? Mm-hmm. And here, when x goes to 2, do you see the limit is 1/4? So in this case, we're just missing this point. We only have a hole there. Okay, everybody? Yes. All right. Okay. Yeah, this is usually what happens when you see a rational function. You think about the domain. Domain is when the denominator is not equal to 0, right? So when you look at the domain x squared minus 4 cannot be 0. So x cannot be 2 and negative 2. But however, the x minus 2, you can cancel with the numerator. Okay? So in this case, you can simplify a function like this. So you only have a whole here. But x plus 2 is still in the denominator. You will have a vertical asymptote. Did you learn vertical asymptote before? Yes. All right. Let's continue. How about this function? All right. So this function, x goes to 0. Do you see x squared is always positive? Yes. X squared is always greater or equal to 0. And when x goes to 0, x squared goes to 0 plus. Right, everybody? X squared always greater or equal to 0. So therefore 1 over x squared is like 1 over 0 plus, which is, maybe I should put a arrow to indicate that's the limit. Okay. 1 over 0 plus is infinity. Yes, everybody? So this is a picture. When you're going close to 0, the y just goes up. That's infinity. And you can see on both sides. Both goes to infinity. So you can say the limit is infinity. Even though infinity is still counted as does not exist, but you can still use infinity to describe it. Unlike the previous example. Remember the previous example? One side you go to infinity, the other side you go to minus infinity. You know, infinity and minus infinity, they are very different. It's like heaven and hell. Very, very different. Therefore, the limit does not exist. Okay? But in this case, both of them goes to infinity. So you can say it equals to infinity. It tells us more information than does not exist. Oh, so a number, okay, so x goes to a plus. The plus means x is going to a from the right. Positive side. You know, a number a is here. This is more positive. The right hand side is more positive. The left hand side is more negative. So this notation means x is going to a from the positive side, from the right. And therefore, x goes to a minus. It means x is approaching a from the left, from the negative side. So yeah, both sides. Yeah, we'll talk about that more. So here we're talking about limits, and later on we'll talk about one-sided limits. Then you will see this symbol more. Yes, good. Very good. All right. So, and here you can see when you compute the limits, you can look at the formula, or you can look at the graph, right? Or you can construct a table. See, x goes to 0. Let x be plus or minus 1. Let x be plus or minus 101. It's smaller, 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 right? Look at your y. Do you see it's getting bigger, 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 bigger? Yeah, it goes to infinity. So 3 ways to find the limits. You can use the table, you can use the graph, and you can look at the formula and calculate. Okay? Algebraically. So again, look at this problem. We can use our calculator. Right? When x goes to 0, we can plug in x is 0.1. Do you know how to use your calculator? Right? We plug in x is 0.1. So 0.1 squared plus 16 take square root minus 4 over 0.1 squared. Okay, so you plug in your numbers in your calculator, and you get these. Do you see? It kind of stabilizes at 0.125. So you can say, I think the limit is 0.125. Okay, everybody? So this is using your calculator and construct a table. In your homework, you have some time like this, but not the homework one. I mean homework two. Okay. Or you can graph the function. So do you know on the online there is something called like GeoGebra or Desmos? Then you can input the function and they give you the graph. Okay, everybody? So you can use those to draw the graph. And then you can see, oh, here, this is our limit. Even though we have an open circle here, right, everybody? That means this point is not defined. But we can tell this is the limit. And this is point 1, right? This is point 2. And then here will be 0.15, right? And the number between point 1 and 0.15 is 0.125. So it matches with this answer. Okay, everybody? And now, let me teach you from the formula, how do we get the limit algebraically? Okay, let's do that. And usually, in the exam, you're going to do this way. Okay, compute the limit algebraically. So, let's do it. Okay, so step 1, we want to plug in the number, right? So we want to plug in 0. If we plug in 0, you get 0 squared plus 60 square root minus 4 over 0 squared, right, everybody? Okay. Oh, did I press something wrong? Okay, never mind. Okay, so this is 0, right? 0 squared is 0. Well, 16 is 16. What is square root of 16? 4. 4 minus 4 is 0. Oh, this is 0. Do you see the denominator is also 0? The bad guy. We need to find the bad guy. Okay, let me get this thing away. All right, we need to find the bad guy. So we come back. Remember the steps here? When we see the numerator and the denominator are polynomial, we can factor it. But do you see here, we don't get a polynomial. We get a difference of square root. So if you see difference of square root, so square root something minus square root of something, you multiply by its conjugate. So conjugate means it's almost like the same thing, but instead of minus sign, you put plus sign. Okay, everybody? So come back. All right. Okay, so come back. Here, we get limit x goes to 0. Square root of x squared plus 60 minus 4 over x squared. We multiply by the conjugate. So the conjugate will be almost the same thing, but instead of minus, you put plus 4. And when you multiply something, you make sure you multiply it on the numerator and denominator, so you're not changing the problem. The effect is like you multiply by 1. Right, everybody? You multiply by 1, you're not changing the fraction. Right? They're still equal. All right. So, yeah, difference of square roots, you multiply by the conjugate. Why do we do that? It's because we're using the formula a plus b times a minus b is a squared minus b squared. The square will get rid of the square root. Okay, everybody? So this is like A. This is like B. This is like A. This is like B. Therefore, you get limit x goes to 0. Do you see the numerator? You get a squared minus b squared. So your a squared will be square root of x squared plus 16. Square minus, what's your b? Yeah, minus 16. And your denominator, just keep it. So far, so good, everybody? Yeah, that is why we multiply by its conjugate to get rid of the square root. All right. So square and square root cancel. We have x squared plus 60 minus 16. So far, so good, everybody? We get rid of the square root. What do we do now?
Actually cancel the
16 first. Yes, we cancel the 16 first. Maybe let me do it slowly. Because I'm so afraid that you would think, okay, so let me write it down here. Be careful. If you have x squared plus 5 over x squared, can you cancel the x squared and say that's 5? No. Okay, so this is not 5. We cannot just cancel x squared. So you have to make sure the 16 cancel, and you have exactly x squared and x squared. Then you can cancel the x squared. Right, everybody? That's why I separate into two sets. Here, we cannot cancel the x squared if it's an addition. Okay, we have to make sure it must be a multiplication. Then we can cancel. All right? Okay, so now, yeah, we can cancel the x squared. Do you see this is the bad guy? The x squared, when x goes to 0, it makes the numerator and denominator 0. So that's the bad guy. We have to leave. Right? We find the bad guy and cancel it. All right. By the way, if we cancel x squared, what's left on the numerator? 1, right? Not 0, right, everybody? Okay, so 1 over x squared plus 16 plus 4. And please, as long as you still have x in the expression, you have to put the limit every step. Okay, everybody? So, know it? Because it's very important. You must carry the limits every step as long as you still have x. But the next step, see, we're going to plug in x is 0. Okay? We plug in x is 0, so the next step we don't need to put the limits because we are plotting in x is 0. So 1 over 0 squared plus 16 plus 4. What's that? What's square root of 16? 4 plus 4? 8. 1 over 8. And do you know 1 over 8 is actually 0.125? Yes? So this is our answer. And actually from the table and the graph, you can just guess the limit should be this number. You conjecture the limit should be this number. But the actual proof is you look at the formula and compute the limits algebraically and get the answer. Okay, everybody? Yeah, so in the exam, when I ask you a problem, I expect you to work on the formula and find the bad guy, cancel it, then plug in the number again to get the limits. Okay, everybody? All right, let's keep going. Estimate the value of sine pi over x. when x goes to 0. So here, given the picture, you see when it's getting close to 0, you oscillate faster, 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 faster. Right, everybody? In this case, I would say the limit does not exist. Because you don't have a number that you're getting close to it. Right? It's actually the interval. You know, sine and cosine is oscillating between -1 and 1. So you get a range. And you're not getting close to a specific number. So in this case, limit does not exist. So D and E. Okay? So limit does not exist. You can think of 3 cases. One case is it actually goes to infinity. Right? It actually goes to infinity. And second case, when it goes to minus infinity, right? It's not approaching to a number, but it's approaching to minus infinity on both sides. And the third one is really does not exist. You cannot describe it. Like this case is oscillating between the two numbers. You cannot describe it. Another situation is when your left side limit and your right side limit, they do not match. In this case, the limit also does not exist. Okay, everybody? So in the exam, if you are able to use infinity or minus infinity to describe it, please use that. Okay? And your use does not exist when you really cannot find a number to describe the function approaching to. Is that clear, everybody? Good. Okay, now one-sided limit. That's when you have the a plus and the a minus. See? Yes. So suppose f is defined for all x near a, with x is greater than a. So greater than a is on the left-hand side or right-hand side? Right-hand side, yes. And if f of x is arbitrarily close to L for all x sufficiently close to a, but with x greater than a, then we write limit x goes to a from the right, f of x equals to L. Let me draw some picture here. Okay, let's see. Let me also get 1 and 2. Okay, let's say we have something like this, and or something like that. So this is f. And here, a plus means we're getting close to a from the right. Right, everybody? So let's look at the picture. And if I ask you what's the limit when x goes to 1 from the right, f of x, what's that? 2. Yes, everybody? We're getting close to 1 from the right. So yeah, we're on the right side. We're on this piece. Imagine here, go, 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 go. Oh, my y is approaching to 2. Right, everybody? So the limit, x goes to 1 from the right side, f of x equals to 2. All right. How about on the other hand, when x less than a, so we're approaching a from the left. What's the limit when we're approaching it from the left? 1. Right, everybody? So that's 1. And what is f of 1? Do you see this is an open circle? This is also open circle, so the point is missing. So what's f of 1? Is 0? Do you see it? No, there's no point there. So that's not, we use undefined to describe the function value. So undefined. Okay, so everybody keep in mind, for function value, okay, if you don't get a number, that's undefined. We use this terminology to describe the function value. And we use does not exist to describe limits. Okay, everybody? So don't use undefined to describe limits. Limits used does not exist. the function value used on this one. Is that clear, everybody? Okay. All right. In this case, see? In this case, because so the left side limit and the right side limit must equal to the same number, then the limits exist. In this case, you see the left side limit and the right side limit do not match. In this case, the limit x goes to 1 f of x does not exist. Is that okay, everybody? Yeah, this is the picture. Left side limit and right side limit do not match. The limit does not exist. Okay, oops. I didn't erase this. Okay, so, all right. Example 5. Please do the following. How about I ask you, you tell me the answer one by one. Okay. Blaine, what is the limit when x goes to 2 from the right? Mm-hmm. Plus 1. Yes. So from the right, we're here. Right, everybody? So then we're on this piece. We go. Oh, okay, it's getting closer. Okay, so very good. That's 1. Okay, next Will. How about when x goes to 2 from the left? Yes. Right, everybody? So we go to the left. We're on this piece. Go. We get 3. Good. Dylan, how about x goes to 2, g of x? Yeah, it does not exist because the left-hand side and the right side limit do not match. Right, everybody? Okay, Paige, how about x goes to 5 from the right? It will be 2, yes. Right, so we're here, we're on this piece, getting close to 2. Okay, next, Mackenzie, how about x getting close to 5 from the left? From the left. See, it's also 2, right? This is also 2. And how about the limit when x goes to 5? Limits. You're getting close to it. Does not exist? Do you see the left side and the right side match? Yes? So it's 2. So the limit is 2. Okay. Look at the difference between here and here. So at 2, your left side limit and the right side limit do not match. So the limit does not exist. Right? But at 5, the left side limit and the right side limit, they match. So the limit equals to the same number. Okay, everybody? Let me also ask you, what is f of 5? Joseph, right? What's f of 5? F of 5. When you look at 5, do you see a solid circle? Yeah, 1.2. Okay, everybody? So f of 5 is 1.2. In this case, do you see the function value and the limits? They are not the same. Because this is an open circle and the point is the function defined somewhere else, not back here. So that's why the limit and the function value do not match. Okay, let's do more. How about this graph? This graph is more complicated. Okay, let's see. Down J, right? What is the limit when x goes to 0 from the right? Goes to 0 from the right. 0? Okay. Do you see the function is oscillating? And what do you say the limit? So you get a range between 0 and 2. So you're not getting close to one number, right? Everybody? So what do you say if it's oscillating? Yeah, does not exist. Okay, good. Layla, when x goes to 1 from the left, what's the limit? 1. Yes. Right, everybody? We're getting close to 1 with other speed, so y goes to 1. Plane. How about the limit x goes to 1? Does not exist because your right side limit and the left side limit do not match. Right, everybody? So the limit of 1 does not exist. Okay, Will, what's the limit x goes to 2?
1.
Yes. Right, everybody? Because both sides match. Both equal to 1, so the limit is 1. All right. Dylan, how about 4 from the left or right here? Plus is up from the right, and it's infinity, right? Actually, from the left, it's also infinity. Yes? Okay, so we say infinity. Yes. Let's keep going. How about 5 from the left, right, Paige? Yeah, very good. Negative infinity. Okay, what is f of 1, Mackenzie? F of 1. So 1 here. Do you see this solid bracket here? Yes, that's 0.5. Very good. Yeah. You can roughly say 0.5. Like last problem, I know that number is slightly higher than 1, so I guess 1.2. But in the exam, I was trying to make sure the point of 1 was integer, so it's not, we don't need to guess. In the exam. Okay, good. And Gabby, what's f of 2? Undefined. Yes, everybody, you see, we don't have a solid point there, so this is undefined. Almost there. Joseph, what's f of 3? Okay. Do you see f of 3 that this is continuous, it's connected, it's not, you don't see a hole there? It means that point is not missing. So what's this point? 0.5. So our f of 3 is 0.5. And okay, that's it. Let's continue next class. Have a nice day. And please do your homework. You can do it again and again until you get perfect scores.
Hey,
Yes.
Professor, with undefined and do not exist, that means the same thing.
Okay. So it both means we don't have a number. It's not equal to a number.
Okay.
So, but the undefined, we use this terminology to describe functions. Does not exist. We use this terminology to describe limits.
Okay.
Yes.
Thank you.
You're welcome.